Preparing to live stream the meeting.
Awesome.
Is there a way to just like automatically admit all?
I don't think so, which is a little bit annoying.
Yeah, you're gonna have to. The pain of hosting. You're gonna have to keep an eye out. Just make sure like your Zoom info is in another like how you say it, like tab or window rather, or screen. That's the word I'm looking for.
Oh god, I got everyone again. Let's go.
As of yet,
Make sure to ping the Discord.
Rewatching.
Yep, I did.
Beautiful.
Yeah, there's 3. Yeah, people are slowly like more and more people are joining the YouTube stream.
Good question. Does my name tag say DSCU Ottawa?
Yes, it
Oh.
does.
Yeah.
Oh yeah, because
That's 'cause
I
you're the
use
host.
that account. Yeah.
Yeah.
So like this is the second time where like the software messes up my name.
You are DSU Ottawa. That's
Yeah, that's fair.
encompassing everyone.
Admit.
Actually, that's a good question.
All right, 21 people in the room so far. I'd say it's pretty good.
By the way, Adam, do you see the option for polls?
I do see the option for polls.
Okay. Well, it shows you the polls. I don't know if you can edit them.
I can edit them.
Okay, perfect. If you can just see it, like I forgot to send this to you, but like if you could see if it's complete and if it's missing like any last things, it should be
Oh,
fine.
yeah, I'll look over it right now. What topics? Good job, Rick. Anyways, 7:06. Should we get this started?
Yeah, might as well. I think it's slowed down in terms of like people joining in.
Yeah, we have 23 so far.
We also have
Much.
15 on YouTube, so I don't know if that's mutually exclusive, but I guess we'll just move forward.
All right. All right. So let's get this started. I don't want to keep you guys waiting for too much longer. So a quick introduction, I guess. My name is Adam. And over there on my left, I don't know about you guys, is my buddy Ahmed. He's also,
Hello?
I guess you can introduce himself.
Damn, wrong direction. My name is Ahmed. I was trying to fist bump you, but I'm also a learning and dev exec, and we're both running this workshop. And we'll just hand the mic over briefly to our team lead, Skyla.
Hey everyone, I'm so excited you're here and thank you for taking the time to join us tonight. My name is Skyla, and as Ahmed said, I am the team lead for DSCU Ottawa. So before we begin, I'm going to do a little bit of an explanation as to what DSCU Ottawa is. So DSC stands for Developer Student Clubs, and we are actually part of a giant network of DSCs across the globe. In North America alone, there's over 200 different chapters at each university. We are also partnered with Google, so all the tech we can give you and all the cool swag we get is all coming directly from Google. So we do networking events, we do midterm prep events, we do tech workshops, and we just really give you guys a foundation in programming, coding, and just anything you need for your career in computer science. So if you're interested in being part of our community and part of our developer club, please check out the link to our website. I think it's on your Discord as well as it's in the chat. And sign up to be a member, join our mailing list, and get awesome swag, cool updates, and network with people from Google and other companies in the tech industry. So yeah, I'll pass it back to your host tonight.
Thank you. So like I said before, we're just learning and dev execs, which means we're just responsible for running workshops such as these. And if you guys want to check out more of the workshops that are coming as we go along the year, feel free to check out our website. If somebody doesn't post one, I'll post one by the end of the meeting so that you guys can check us out and see more of us in terms of our workshops anyways. And without further ado, Adam, do you want to start sharing your screen?
Yeah, of course. I guess we'll start with the blank Python document. So share screen. Screen one. Okay. Perfect. Let's start from the top. Is it live, by the way? Just want to make sure.
Yep, you're all good to go.
Awesome.
Yeah, it's kind of, I don't know if you guys can see this, but in the Zoom call, it's a bit compressed.
For me, it looks okay.
Looks good on my end.
Yeah, all good here.
Oh, sorry, my bad. It's my computer. Anyways, we can continue.
For sure. I guess we should start from the top with Big O. Ahmed, you want to?
I just want to go over, actually, sorry, there is a section about pedagogy. I
Oh,
don't
I
know
didn't see that.
that word still. Yeah, I just wanted to like mention it briefly, which is that this workshop is going to be 2 hours. You probably know this from the event page, but given that we have a compressed schedule, the material in of itself will be compressed, and the focus is going to be focused more on live coding and answering of questions. We really want to make this workshop as tailored to you guys as possible, while still including as much material as possible to like cover a broad range of topics in the test. Feel free to ask questions. We really, really encourage it. And we will all, and if you guys have like extra practice questions that aren't part of the live assignment, we would be more than happy to help you guys. That's it. We cannot get, I'm just gonna say it out now because of the time constraints, we can't get to every single question, but we will do our best to answer as many as we can and answer like the best and most relevant ones because we've taken this course before. Well, yeah. And without further ado, we can, I think, yeah, let's move into big O notation because you guys covered it in the lecture. I just remembered. I wasn't sure if you got to that yet. Do you mind scrolling down?
Yep. So start big O.
Okay. Sorry, I was checking it. Anyways, could you go up to the graph, by the way?
Yep.
Yeah. So basically the idea of big O is that it gives you a way to create a function to tell you how long your algorithm will take based on the number of inputs that you have, right? And I'm sure you guys have covered this before. If you could just highlight the first line. Yeah.
This one?
No, like the first text line.
Oh, gotcha. Over
Yeah,
here.
yeah.
Oh, I
Sorry.
did this thing again.
So like it says here, given a number of inputs n, how long will it take for an algorithm to solve a problem in t units of time, be that milliseconds, minutes, hours, etc. And f and g are real valued functions. And big O just gives you kind of a way to compare algorithms with each other to see how well they work given a number of inputs. So like it says here, fx is O of gx if there exists two positive real numbers c and x0 such that the absolute value of fx is less than or equal to c times g of x. I know that's a lot of math to throw at you, but basically, if this is unfamiliar to you, if you could scroll down a little just so that people can see the graph.
Yep.
No, the graph itself.
This one.
No, the top one, the picture.
Oh,
yeah.
Oh, okay, gotcha. Sorry.
The way that it works is that you'll notice that the blue function grows at a rate much, much faster than the red function. And the red function is f of x. And the idea is that c times g of x will, after a certain number, be way more costly in terms of time than f of x ever will. And that's the whole idea, is that it's comparing algorithms given functions and trying to map how long it'll take in terms of time. And if you scroll down, I also did like a little graph. You guys don't have to know this code, but I did a little graph to show the relation, like the comparisons of different runtime algorithms. So if you scroll down a little, the graph will show you like a legend. And
zoom out.
If you scroll up, you might want to zoom out a little more. Yeah. You can also, yeah, I don't know if you guys can see that, like type in the chat if you can see it, but the idea is that you have, well, you can read the graph yourself, but it shows how as the order of the function and the complexity of the function goes higher and higher, it takes more and more time to process the same amount of inputs. And you'll see that it grows much, much quicker than the others. And that's why we use O of n. So for example, O of log n is, or sorry, log n is O of n, right? It takes less than O of n for any given number of inputs. And you always want to map your algorithm to the closest and most sensible function. Like if your algorithm takes like n time, you don't want to say it's O n to the 4. I mean, it's technically correct, but you want to keep it as accurate and as minimal as possible. But that's not being covered on your test, and we just wanted to kind of give you, like, once again, we're just giving you like a little refresher so that you guys are, or an extra lesson so that you guys are more prepared for future assignments in this. Anyways, the other thing is that with O of N, we're always considering worst case, which if you scroll back up to that bar graph.
Oh,
yeah, there's different cases, like the complexity of the algorithm will change depending on the inputs you give it. Like, for example, if you're sorting a list and the list is already sorted, well, it's not going to take much time. It only needs to run once and it knows that the list is sorted. And so because of that, we always want to take our worst case, because our best case isn't really useful if we're giving it like silly data. An average case is very, very hard to like determine, especially when there's literally millions of combinations of like sorting arrays or strings or whatever you're running. And so worst case is always what we want to consider when talking about runtime complexity. By the way, it refers to the bar graph if you zoom down or scroll down rather.
Oh, right there. Perfect.
Yeah, there it is. Okay. Okay. I think we can come back to these questions if people are interested in this, but I think it's best if we go over like the other topics like lists, methods, and iterations.
For sure. Oh, let me just put this on the side. Anyways, do you want me to take care of this, lists and iterations?
Yes.
Okay, perfect. So to do a quick refresher, I'm going to open up OneNote just to make sure everyone sees my OneNote, right?
I can, guys. Type in the chat if you can.
Yeah, perfect. So I'm going to kind of visualize what a list is. So in Python, we have a little variable, right? Let's call it A. Then A is equal to, I don't know, 10. All a list is basically kind of a bucket filled with these variables. So let's say A, B, C, and D. And then every single one of these variables has, I guess you can call it an ID, right? And Python terms is called an index, right? So let's say this one is ID 0, ID 1, and so on and so forth. And these IDs are kind of sequential. So if we actually draw out the list, we would have A, B, C, D, right? So you have a list of 4. And then the IDs would be, or the index would be 0, 1, 2, and 3. And this is kind of the basic parts of a list. It's a way to store information, but a lot of it, and have it easily organized. So now let's actually do some examples. So first of all, we have our simple list is just an array or a list of 6 numbers. And then we also have a list that can contain not only numbers, but strings. And once we start diving deeper into Python later on during the semester, you'll notice that there's a lot of different data types you can also fit in there. Like, for example, you can fit in Booleans. So if we go over here, we simply type in true. This is also okay to have in a list. And now you can also start having, this is called a matrix. Oh, I see in the chat right now, what is the difference between a list and an array? In essence, they're really the same thing. Python just has a different way of calling arrays lists. And I will be doing this a lot. I'll be doing, kind of saying both lists and arrays interchangeably. Not the best thing, but I do apologize ahead of time. If you want to go a bit deeper, then you would say that arrays are kind of are a bit more defined. It would say arrays can only have this many numbers, while lists, you can kind of like expand it and shrink it. But for now, arrays and lists are really the same thing. Perfect. Thank you, Scott. Just for say that. Anyways, we can also have lists and lists. So for example, let's have a variable called A. And then we can have one list. So 1, 2, 3, 2, 3, another one, 4, 5, 6, and another one, 7, 8, 9. So let's say we want to print out A and just see how this looks. So A will look like this. So we have this, the list with 1, 2, 3. Now let's try indexing the first item. So print A 0. Now we get the first item here. And obviously, if we wanted the second one, we would type in 1, 4, 5, 6. And because the next item in the list is an array, we can kind of repeat it. So say we grab the second array, so array 1, because arrays start at 0. And then we say we want to select the last item in there. Yet again, that's 2, because it's 0, 1, 2. And then over here, you see we printed out 6. So having arrays and arrays, or lists and lists, is possible. And you can have it like an infinite amount of lists. So you can have a list and a list and a list and a list and a list. Yeah, Inception, basically. And this becomes really useful because a lot of people use lists and lists to kind of simulate 2D. So you have your x coordinates and your y coordinates. Then you can have 3D with x, y, and z with 3 arrays and arrays. Next up, we have indexing and slicing. So yet again, let's just create a simple array. Same at A as usual, 1, 2, 3, 4, 5, 6, 7, 8. What I'll actually do is I'll actually start with 0 as well, just to make it a bit more simple and easier to visualize the slicing. So this indices start at 0 and end at n minus 1. So the number of elements of the list minus 1. So let's say the easiest way to print the amount of items in the list is using the length operator, which is just len. So we can do print the length of A. So doing that, we will get 9 because there's 8 plus 0, so 9 items in that list. I know that kind of makes no sense. And afterwards, as I showed above, right, if we just want to grab the first item in the list, we just do A, and then the actual position of that item in the list, so A is 0. And again, they'll print 0. And now let's say we actually want to print out the last number in that list. So print A, and then let's actually make it a bit more simple to visualize. We have the length underscore of A is equal to length of A. Right? And afterwards, we want to print A, an item in that array. So we can do length of A, and we'll have to do minus 1 because, as I mentioned before, lists start at 0. So yet again, over here, you'll see I'll print 8, which is the last item in that list. There's also a little cheat sheet you can do, a little trick with minus 1. So if you always want to grab the last item in that array, you can simply do A index minus 1, which will print out the exact same thing. And that was the thing right underneath this comment. I'll reorganize that. Next up, this is called slicing. So let's say I have an array, as I mentioned, A, and I want to grab from the 5th item to the 7th item, right? Instead of having to do A4, A5, A6, and then kind of having to concatenate all of those things together, we can use slicing. So we can do print A starting from position 4 to position 6. I use a semicolon by accident. So just for simplicity's sake, I'm going to kind of comment these out, make it easier to see. We have 4 and 5. Next up, we can also do negative slicing. We can do print A, let's say, -5 to -1, right? And here's the cool thing about negative slicing. The way it works, it's, as I mentioned with -1, you're kind of just starting the lists from the other way. So let me visualize it with OneNote again. So over here we have a list of 0, 1, 2, 3, 4. Right? Normally the array would start with 0, and then 1, 2, 3, 4. These are the indexes for each one of those items. Now if we go the other way, right, this would be -1. So this is 4, -2, -3, -4. So basically positive numbers go, oh crap, positive numbers go this way, and then negative numbers go that way. So that's the same thing with negative indexing. You can do that. Next up, list methods. So same thing with, for example, strings. What about 0 and then negative indexing? You can't really have negative 0. So 0 would just be the first element. The last element, as I mentioned before, is -1. So that will always be the last element in the array. Perfect.
I think he's referring to, or I think they're referring to like the first element specifically in any array. Like when negative indexing.
Yes. Okay. You want to maybe answer that then? Because I'm also a bit confused with the question.
Can you go back to the document?
Yeah, of course. Or
Sorry
this
to
one?
kind of like take your steal your thunder, but like
No.
if you go to 0, -4 would be the, well, wait, there's, sorry, yeah, -5 would be the first element. And basically you just, the negative of whatever the length of your array is, because with negative indexing, it always starts at 1, because like Adam said, you can't have a -0. So unlike regular arrays, negative indexing starts at 1 and ends at n, which is the length of your array.
Perfect. Thank you for clarifying that. Anyways, to continue, list methods. So to clear stuff up here, I'm going to quickly debrief the difference between a function and a method, because you'll be hearing me say methods a lot and you'll be maybe kind of confused of what that means. So methods are still functions. It's that they're attached to an object. So when you declare a function, you just say define function. It's not really attached to anything. But with methods, you'll always see that you have the object and then dot the method. So that's a quick way to kind of see what's a method, what's a function. If you call the quote unquote function with dot and then parentheses the name, that's a method. But anyways, that's a bit off point. I just wanted to clear that up. So next up, let's say we have an array called fruits, and then that array we have apples, bananas, and cherries. So let's say I want, like, let's say this is our shopping cart, and I want to add another item to that array. The easiest way to do that is just using the append method. And as the name suggests, append just adds something to that array. So if we just do fruits dot append orange, you'll see that if we print fruits now, it will give us an array of 4 items, and the last one is orange. Because append will always, oh, I think, did I misspell banana? I did. Append will always add that item at the end of the array. Afterwards, we will kind of show a way to do it like anywhere in the array. Anyways, let's say I finally finished my shopping adventure and I bought all those items. I want to get rid of all of those items in the array. Instead of going manually one at a time saying fruits 0 is equal to nothing, right? The easiest way to do that is just fruits, another method, dot clear. And now if we print fruits, which look at that, there's nothing in the array. Super one clean little method to get rid of everything. It's beautiful. Next up, let's say we want to kind of copy an array. So let's say we have another array called A, right? And then actually just make it the same thing as fruits. And then we want to set another array equal to A. So B is equal to A. And now we'll do C is equal to A dot copy. So what I did right here, I didn't explain right away, is I have 2 different variables, both being equal to an array. However, the first variable I just set equal to the array, and the second variable I actually called a method called copy. From what it seems so far, it seems to be the exact same thing, right? If I print out B and I print out C, I will have both arrays being the exact same. So far they look identical. Sorry for the voice crack. So let's see what the actual difference is. So let's say I modify array A. So let's say A, let's say the first item in A is equal to pairs, right? Now let me print out B, and let me print out C. Actually, let me do this as well, just to make sure it's easier to see the separation. So what you'll see right here is that B was changed, but C wasn't, even though I only told it to change A. So while I assigned B equal to A, I assigned it to the exact same spot in memory. We'll get into memory afterwards, but the easiest way for me to explain this is that B is exactly A. It's the exact same spot in memory. So if I modify A, I will also modify B. However, because I said C is equal to a copy of A, C will not be modified because it's the same values as A, but it's not directly attached to A. In other programming languages, this is referred to as shadowing, right? I'm not the same object as the object is giving the shadow, but I'm copying what it does. So that's what we refer to as. So this can actually cause a lot of errors. You're modifying one array and you're modifying the other one, and you're like, what is going on? So I find it's always easier to just use the method a.copy and just kind of create a copy of that array. Ahmed, do you want to add anything before I continue? Or is everything so far good?
I mean, so far so good. You're not swaying from any of the material, and you're doing it pretty well. So
awesome. Just want to make sure I'm on track and not starting to rant out.
yeah.
Let's say I want to count an array. So what does count mean? So let's actually use that. So fruits.count. So we'll use A, and I will kind of get rid of this. So we have A staying the same. So let's do A.count. Oh, sorry, it actually gives me an error because I need to pass an argument. So I guess I'll just explain it right off the bat instead of trying to like improvise with it. So count does what the method says. I have the array A, and I want to check how many times does this thing show up in the array, or more specifically, how many instances of this item is found in that array. So let's say I do. I know we have banana spelled wrong in the array A, right? So let's see how many times it's spelled banana wrong. So let me run that. Over here, I see that banana shows up once in my array. If I type in some gibberish and I run it again, it'll show up. It never shows up in my array, so it gives me back 0. And if I have banana spelled wrong multiple times in my array, as you can guess, it'll give me 2. All right, so this is easy way to think of it. Next up, extends. This is super, super useful. So let's say I have an array called A, and that's equal to 1, 2, 3. B is equal to 4, 5, 6. And now I say A.extend B. I actually want to see in the chat, can you guys guess what extend does? Don't switch it up. Just, I want to see if you guys can actually get what extend does. So, okay, I have one person, Raymond, who says that it's going to be 1, 2, 3, 4, 5, 6. Pretty good guess. Any other? Oh, 1, 2, 3, 4, 5, 6 as well. I'm guessing everyone's just going to say the same thing. So yeah, let's actually see. So let me print A. Oh, look at that. It's 1, 2, 3, 4, 5, 6. Oh, maybe repeats the last and next. Now, almost there. Yes. So as the name applies, it kind of adds on to the array. So think of it, I guess, as a pen, but instead of actually setting it to one spot in the array, you kind of like, yeah, you extend the array. It's in the name. One thing I do want to point out here real quick is that on every every other thing I've done, I've kind of, let's say I set a value to A. So let's say C is equal to A. This is a bit off topic, but I want to make sure we understand the difference between destructive functions and non-destructive functions or methods. So let's print out A and print out C. So C actually gives me none. And in my personal Python experience, I've always had this issue. Like, let's say like I do call extend a lot, and when I first learned about it, I would always set like the variable after the method. So I expected that A would return me the extended array, but it doesn't. And this is what's called a destructive method. So it will actually destroy the original value and replace it with the new value. So when you come to your actual Python experience, I recommend strongly watch out about it. If you're asking yourself, why is this method not returning anything? It's probably because it's destructive. So a quick little side note. Anyways, what if the list is with strings? Does the method still work or behave differently? Let's check out. Let's check it out. So let's say we have A with 2 strings, and then B with another 2 strings. Can anyone guess if it's going to be the same? Spoiler alert, it's not going to be the same. It is going to be the same. And I'll explain to you why. So yet again, we have 1 as a string, 2, 3 as a string, and yada, yada, yada. The array doesn't really care about what type of item is in it. It's fine. It's going to always be completely the same because that item takes a specific place in that array. And as long as that item, same data type, doesn't matter. Yeah. As long as that item is in that specific spot in the array, it doesn't care. Next up, so over here we found how to count the amount of items in the array. That's great. But let's say I want to find out where that item is. So arrays have a really cool method called index. And you've probably already heard me say index a lot throughout this workshop. Let's index as part of the array. Index is a specific place in that array. So let's say I want to index A again. So A, actually no, because I already reset it here. So A dot index apples, right? Apple. So let me set this equal to index, because over here, index is not a destructive method. It will actually return something and it will not destroy A. So yet again, a little reminder about that. So print index. Over here, you see returns 0. Now don't be confused. Apple doesn't show up 0 times in A. Rather, it shows up at position 0. So now if I do print A index, you'll see that it'll print out apple. Now, for example, we have banana show up twice in the array. What would happen if I index banana? It returns 1. All right. And here's the thing. It will only, once it sees the first, so A of 0 is equal to A of index because apple is in the 0 position of A. So if there's multiple same items in the array and you index one of them, it will return the first one. So that's a little thing to make sure you know of. I do need, I'm going to kind of skim over the rest because I do feel like I'm taking a bit too much time. So quickly, let's just do insert. So yet again with A, let's insert banana. Spelled wrong. But you might be asking yourself, what's the difference between insert and append? This is where it gets really cool. So I can specify where in the array I want to have banana. So if I want banana to be at the beginning of the array, I'll just say 0. So print A. You'll see that banana is now at the beginning of the array. And make sure you see this, that it doesn't destroy apple. Apple is just pushed in front of it. Banana takes its spot. Now let's do the opposite. Let's do pop, right? So I've actually ran into a lot of issues with this where I tried popping the value. You have to pop the index. So a dot pop 0. So I just added banana. Now I want to remove banana. If I run that, you'll see that it returns to normal. A dot remove is similar, but this time, instead of putting in the index, it will actually use the value. So now if I remove, let's actually finally get rid of the banana because it's spelled wrong. You'll see that it will remove banana. And not only the first one, but, oh, crap, what did I do wrong here? Oh, sorry, a dot remove. My bad. A dot remove. You'll see, I need to print out A. It removes all instances, the first instance of banana. Not all of them, the first one, my bad. I got confused with something else. And then for our last little trick here, let's say I want to grab my array and just kind of flip it around, right? Arrays also have a quick little method for it, just called reverse. So let's say I make a new array called numbers, and that's equal to 1, 2, 3, 4, 5, 6. And now, let's say I do a dot reverse. This is a destructive method, so it will not give me a new array, rather it will modify the current array. If I do print a, you'll see that now instead of it being apple, banana, cherry, it's now cherry, banana, apple. There's also sort, which as the name applies, sorts a bunch of items in the array. Can you a dot pop? Yeah, of course. Seriously. What do you want me to pop? You want me to pop like 0, like the first item, and see what happens after reverse? Cherry is removed because yet again, no, only pop. Okay, this is actually going to give you an error. I wonder if it's actually going to lint it. No, it's not. Oh, this does give you an error. Oh, I guess, yeah. So I just learned something new today. If you don't pass in an argument in pop, it will remove the 0 index. So I just learned something new. That's really cool. Next, let's do sort. So I have my reversed array. So, oh, I actually did the wrong one, numbers. By the way, if you're not, yeah, it's the same thing, you're reversing items. So now it will be 6, 5, 4, 3, 2, 1. So now let's say I want to go back to 1, 2, 3, 4, 5, 6, but I don't want to use reverse. I want to use something else. And because I know 1, 2, 3, 4, 5, 6 are their values are growing, I can use sort. Yet again, this is a destructive method. So I will have to do numbers dot sort and then print out numbers. So now we went from 6, 5, 4, 3, 2, 1 to 1, 2, 3, 4, 5, 6. Anyways, this is it for arrays. I think I've spent a bit too much time to it, so I'll pass it on to Ahmed to continue.
Yep, sorry, I was just typing something in the chat. And okay, I think, is it okay if I share my screens if I'm taking it over? Because
it'll be easier.
Yeah, just to save your document so I can see all the changes you made.
That's saved.
Okay, let me just refresh. Okay. Sorry, what were you gonna say? I cut you off.
Oh no, I was just seeing in the chat how Ray asked how to sort in the dot sort function. I did kind of skim over it real quick. So I'll just type it in the chat real quick.
I can just quickly go over it and explain to you guys.
Be faster.
If you don't mind just watching the YouTube and what's it called, Zoom chat, as well. But feel free to interject whenever you spot something wrong. Mm-hmm. So let us know if you can't see the screen. But the way that sort works is that it takes numbers or strings and it puts them back into order. So if you have, for example, a string of words like this, I don't know, names equals, sorry, I guess I'll rename this words equals apples, zebras, bees. I can't think of any. And if you were to print words.sort, it actually returns an alphabetically what's it called, sorted array, which that's strange. I don't. Can you guys see this array?
Yep. There's a lot of different print statements, so maybe that's why.
Yeah, it's just. Sorry, I have to actually, my bad. I have to actually do this outside of the method, I suppose. There it is. So it returns like an alphabetically sorted array. Just give me a second, guys. I just want to open the chat so I can see these questions live as well in case like I can answer. Okay. And it does the same thing with numbers in that it sorts the numbers regardless of whether or not they're integers or decimals according to natural order. This is going off like kind of getting really complex, but you can specify like objects that have their own order. But it's really complicated and it takes a while. And it's kind of like, it requires a bit of knowledge of theoretical math. So we're not going to get into that. We're going to go into iteration, if that's cool. Do you guys, what if there's a number and a string in the same list? Good question.
Let me guess. So from what I remember, it will actually use the
actually, that's
ASCII values or Unicode values. So I'm pretty sure numbers will come, no, letters, all alphabetic numbers, all the alphabet will come first, and then after numbers will come.
There it is.
Oh.
Yeah, just as I figured, because they're different types. I just wasn't sure if Python would account for that or not.
Oh, wow. I guess I was thinking of some other language then. My bad.
At least, yeah.
Yeah, it returns an error.
Yeah, sorry, I keep switching between Python and Java, so this is kind of a question that I had to double check for. I switch between like maybe 3 languages on the daily. It's hectic.
Yeah, I think JavaScript actually like does the way I thought it did with like using the ASCII values.
Different programming languages have their own like definitions, so you'd have to double check. But anyways, make sure you. Is there any more questions about any of these list methods before we move on, by the way, or are you guys ready to move on to iterations?
Seems good so far.
Yeah, we'll keep an eye out for any, but I think we're just gonna. So, so basically, iteration. Iteration is a way in which, say, we're given an array, right? Like we're given an array of numbers where we have a equals 1, 2, 3, 4, 5, whatever, right? And we want to, and you'll have to excuse me because I have a document where I have these notes up. Yeah, say we have an array of numbers and we want to loop over that array. So what we do is we have a length variable called length equals len a, right? And then we say for every number I, which or n in a range of numbers, we're going to loop over it. And so I'm just going to go over this really quickly and what it means. So basically, what the for loop does is that it allows you to run a piece of code underneath, like a print statement, for example, 10 times. And so that way you wouldn't have to type it out 10 times and run it over and over again, right? So here, take this example. Because we have 6 elements, this prints 6 times, right? And so we're going over 6, like there's, the best way I can explain it is that you're going over a range of numbers and you're usually starting at 0, but the for loop has this thing where you can actually specify the start point, the end point, and how many steps you want to take while you go over this for loop. So for example, say you wanted to go from 6 back to 0, right? So you go length 0, -1, and you print n. You can do that as well, right? So for loops in Python are very like customizable, for lack of a better term, and they allow you to move in any which direction, be it numeric or even in an array. So I'll show you what it looks like in an array. So say you actually just wanted to access the elements of an array in a for loop. Well, Python lets you do that. You go for I in A, and you print A. Sorry, I, my bad. And it does the same thing. And I'll just comment this out so that it's easier for you guys to see. But another thing that you can do with this is that, and this is what makes it cool with Python, is that, oh my God, I'm gonna disable this so you guys don't get bothered by this. So say A was just an actual array of strings, like this, like the fruits, right? I don't have to change anything. I will still do the same thing. And that's the power of for loops. It lets you iterate over an array without having to specify index like this. Like for example, if I wanted to do the same thing, I would have to do for I in range length, and then print AI. And so it really just helps cut things down in terms of typing time, but both of these work and both of these are perfectly valid. And that's what I find kind of cool about for loops in Python. Does print I and return I give the same result when doing this?
Return.
What do you mean? I mean, this isn't a function or a method, so you don't need a return.
I think we should quickly go
misunderstanding.
over the difference between print and return, just to make sure everyone understands.
So like we said, I think you defined methods earlier.
Right, I
don't
talked
know if
about, yeah.
Did you remove it?
No, I just kind of like talked about it, like what's the difference between a method and a function, just
Oh, okay.
verbally.
I'll just go over it here, and I'll methods. So basically, say I had a method and I wanted to make a method called def print greeting, and it would take in a value called name, right? And it would just go print hello there plus name. Yeah, I'm getting to that. But if I add this, so let's say I define this string and I added name to it, return A. So I have these two methods, and the idea behind return is that when you, wait, actually I should probably, do people know what methods are? I should probably ask that. Should I go over?
I mentioned it real quick. By the way, just make sure we say concise. Methods are attached to objects and functions are independent. So that's a function.
Yeah, right. Sorry.
Yeah.
Function. My bad.
Like, and I'm trying to be like the person here, but like I don't want to confuse them because I explained the difference between functions and methods already.
So basically, right. My bad.
No worries.
So given that we have these two functions, what happens here is that if I call this function, if I say print greeting, right? What happens is that it actually prints me a nice greeting message at the bottom here. But if I were to call the return greeting method, right? I guess this is Colab, so it does run in real time. But if I say it, I can set a variable to this, and the idea is that returning gives you back a variable at the very end. So A gets defined as this new string holding the greeting, and I assign, I guess, B to be the value that returns from this method, right? And so I can print B. But for example, if I had C and I set it to print underscore greeting, return only usually applies to when you have a method or function where you want to give back a value. So say you wanted to make like a function, say I wanted to make a function like add numbers, right? And I had number 1 and number 2. So I just want to return number 1 plus number 2. You're making a method or a function with a return statement at the end because you want to make a new value and you don't want to have to keep writing this code over and over again. So you call it externally.
You want me to try to visualize it? Maybe
yes, that would be great. Yeah, I don't have like a pen or anything. So like usually I would draw this out, but
no worries, no worries. I guess I'll share my screen real quick.
Yeah, sorry.
So I'm going to cut you off. Sorry.
Yeah. Adam, I already have it going. Oh, you do? Okay.
Oh, perfect.
I have it open on the Python visualizer, so I can show that later after you're done drawing it.
Yeah, that'd be great as well. So first thing to kind of set it up, I want to talk about the command line. So whenever you run your Python application, it runs in the command line, and that's where you see all your print statements, right? So let's say I draw my command line over here, right? And then over here I have all my Python text, right? Everything all of this text you see here are specifically print statements, right? I am telling my command line to print these values specifically. So when I say print A, oh my God, print A, I tell the computer print this value. And this is why I see a lot of people confused between print and return. Because let's say I open up my shell real quick. So this may look a bit weird. But this is simply just a Python shell. So if I run Python 3, and then I say return A. Or actually, I need to do a function first. So define test, and then return A. If I run test, it will return A anyways. I'm not telling it to print it, but it's printing it anyways. And this is where a lot of people get confused. This is wrong in a way. The only reason that it will print it out is because I am in this shell, and it's just making my life easier. When I run an actual Python script, return will not print anything in the shell unless I tell it to. So let's just get that out of the way. Next up, what does return actually do? So let's say I am a function and I add up two numbers together. So let's say I have 1 and 2, right? And you give me those through the parameters. So you say, Adam, I need you to return 1 plus 1. I will physically hand you back 2. If you say, Adam, only print what is 1 plus 1, I will go to the terminal and tell it, hey, terminal, print 2. So that's my kind of way of trying to explain prints and returns. And as Ahmed already showed, like function-wise, what print and return does, if I assign a variable to the return statement of a function that just prints something, it will return nothing because I'm telling the function, just print it out. I don't want you to return anything. But if that function, I specifically tell it to return something, then I can assign it a variable. So I guess we can quickly go to Skyla, who has the Python visualizer, which will easily kind of emphasize my points. So I'll stop sharing
I
my
just need
screen.
to take over. There we go. Can everyone see that? Yeah, awesome. All right, so I have the exact same code that Adam and Ahmed were working on. So we have our two functions. So this is just for printing. And as you can see here, there is no return statement.
Oh.
However, in this function, we have the return statement here. So let me just do a quick walkthrough or explanation of what's happening. So
Not to cut
over
you
here,
off.
yeah.
Sorry, you're running in Python 2.7. It's going to give you an error.
Better?
Okay, perfect. Yeah, sorry. I'm just going
Yeah. So right here, I'm calling my two my two functions. So what's happening is that the interpreter, it's looking for this function name. So it's going to go up here. It's going to be like, oh, I need to take in a variable. What's my variable? It's, well, Skyla, that's my name. And then it's doing the same thing. So I'm calling this function and it's going to look for it up here. And it's going to see what parameter do I have? Where do I put it into the code? And it's going to return it back to a function here. So over here, we don't have any variable assignments, but in this statement we do. So I have a variable called print variable that's going to be equal to the output of this function. And over here, I have another variable called return variable that's going to equal the output of this function. So, and then over here, we have a couple print statements. So let's visualize and see what happens. So in the first step, it's just interpreting all the different pieces of the code. So the green line is the line that just executed. So it executed this. And the red arrow is pointing at the next line that's going to run. So when I go, whoop. So it's right there, and it's going to execute this statement next. So there we go. This is my output. We have it saying, hello there, Skyla, but there is no return value. And you can see it right here. It's saying there's no return value. So next we go to the return greeting. It's going to say, okay, let's put my variable in here. That's the parameter that's being passed. It's equaling A to this statement right here. And then we're having a return value. So as you can see here, instead of A being blank, we actually have a value stored in there. And we actually have a return value over here. So remember with the print statement, we didn't have a return value coming out of that function. So now let's take a look at what happens when we try to equal variables to functions that have just the print statement or return statement. So again, we're passing in the Skyla to the name parameter. We're running some code. There's no return value. So if we take a look at our print greeting variable, there's nothing that got printed to it. It's just equal to the entire function. However, if we take a look at what's happening here, to speed along, so returned A, so it's going to return this value. And then, well, look at that. Return variable actually has a value now because of this return statement. So print doesn't have a return value. So if you're making a variable equal to the output of a function and there's no return statement, you're going to get nothing inside your variable. But if there is a return statement, then you're going to get a value inside your variable. So that's the key difference there. And then print prints out to the console, but inside the actual code, if you have a variable that's equal to something that doesn't have a return statement, you're not getting any value here. And if you have that return statement, that variable has a value in it now. Are there any questions about this code? Awesome, great. There we go.
All right, sorry, just give me a second while I share screens. Thank you, by the way. I forgot about the Python visualizer for a hot
No
minute.
I did too.
Okay, so we are back in iteration. So seeing as how we've covered functions and methods, I think we can just go back into iterations. I want to see how much time we're given. Sorry, guys, I just got to open up the chat again. Okay, cool. All right. So are there any questions so far that you guys have on what's it called? Loops? Just to give a quick recap, by the way, basically we can either go through numbers, we can customize what or say what type of steps we want to take. So in the reverse direction or in the positive direction. And we can either choose to index them by actual object, or we can choose to index them by number or index in the array. So the other thing is, did we covered 2D arrays in the last?
Yeah.
Yeah. Okay. I'm assuming she gives you 2D arrays in her questions, right? Like in her exam questions.
Not often. But I think
Okay.
it'd be like one of the harder ones, let's say. Like one of
Okay.
the tougher questions
So
probably be 2D arrays.
I'll just go over this then.
Yeah.
So I'm going to copy this because it takes forever to format. But basically, actually, no, I should probably type this out to make it easier to see. But basically, lists can contain other lists. And that can be in tandem with other objects. So for example, if I had 1, 2, 3, and then, I don't know, 4, 5, 6. Right? Once again, because Python doesn't care about the object type, you can put whatever you want in a list. However, usually it is considered best practice that if you're putting in a list, make sure it's just other lists in there, because otherwise it gets confusing pretty quickly, unless you know what you're doing. So for example, say I had this list, this sublist of 1, 2, 3. So I have a list where each, here, it's easier if I just print this out. Let's say I have 4i in A, print A, right? Or I rather. You'll notice that it prints the whole thing, and that's because every I is actually a subarray, and I'll just show you here. Print let's say I have a variable called index, right? And now I said index plus equals 1. So every time I go through this loop, for this for loop, I add the index by 1, right? Sorry, I should probably put that at the end. Well, it loops over this array 3 times, right? And because it starts at 0 and ends at 2, that ends up being 3 times. But you're actually printing the list itself. If I wanted to access the specific element, I would have to say for j in I, because once again, I becomes a list, right? And you're accessing the list in this for loop. And I print j. And there you go. I'm able to print out, sorry, this is irritating me a little. I'm able to print out every single element of this 2D array. Now, 2D arrays are really useful, especially when it comes to like data processing and analysis. And you also will be asked most likely a question like this at some point down the line in ITI. So I really do recommend that you guys get practice on this, just because no matter how much we teach it here, trust me when I say it takes a bit of practice. One other thing I wanted to also mention, which is that you can actually access the index of a what's it called, of a 2D array with in the same way that you access the elements of a list in a 1D array. So for example, if I wanted to print A0, right, that gives me this list. But if I wanted to print the number 3, I would do A02, and there you go. It gives me a it gives me 3.
Yeah, Ahmed, we got a question on the YouTube Live. Could you quickly re-explain the 2D array printing and how that works?
Yeah. Okay.
Yeah.
So
I'll throw it into the visualizer in the meantime.
yeah,
Maybe
actually, that would
help
be
a little
best.
bit more. Great.
Here, I'll just access the link. Whoops. I'll just put everything in here for now.
Actually, would you mind sending me the link to that doc? I can do the visualizer while you guys are doing this part.
Sure. Here. I'll just send it to you.
If you want, I can take care of it. Oh.
Yep, got it. Thanks.
Okay. All right. So am I still doing the visualizer, or am I running it here?
Run it there, do an explanation, then I'll talk about the visualizer.
I would recommend to actually try to print I. I find it would kind of help out just to show like what element we are in the first array. Just like around topic.
Sure.
Yeah, print I.
Like print
And
I
then,
like this. Yeah. That's
and
what I
then
went
on the
over
bottom,
first.
and then underneath that, do for J and I, and then print J, just so they can kind of see.
Oh, I see.
Right.
It does make more sense, yeah. So what happens here is, and I'll just remove this print statement so that you guys don't get too visually cluttered, but for I and A takes every sublist in this 2D array, right? So I takes on the value of 1, 2, 3, or 4, 5, 5, 6, or 7, 8, 9, right? And if I print it here, it prints out this array. And that's what this first for loop is doing. Now on the inside, because this sublist is 3 elements, this for loop will go over this sublist 3 times, right? And it'll print out these elements 1, 2, 3. So starting here, you'll go for I and J, 1, 2, 3, and then for J and I, 1, 2, 3. Does that sort of make sense to you guys? Probably should know this, but what is test 2 covering? Yeah, so as far as actually, I think Adam is better suited to answer this question.
Yeah. Obviously, I don't know either. I'm also I'm currently in the Python ITI class. But from what I gathered from all the lectures is we will briefly cover Big O. Ahmed talked about it a bit, but not into detail because it's not a big point in the test. But probably the main focus of the test are arrays, and this is why we've been spending a lot of time on that, right?
By the way,
for loops.
Sorry to interrupt, but actually, it's not. Big O isn't covered. I don't think she mentioned it in her lecture.
Oh,
but
okay.
That's Vita's class.
Okay,
it depends. Like if you have Aziz, he straight up just ignores that whole concept. But if you have Vita, she might mention it in your final. I don't think she'll do it for your midterms. But again, it's just something good to know.
I know that this morning on Brightspace, she posted some information about test 2. We'll cover everything that we have seen in class/lab/assignments, except for Big O analysis and TurboGrafx.
The one thing I mentioned. Sorry about that. Yeah, but I'd say the big thing on the test would be arrays and using them. So for loops is the big things with arrays. For loops are almost always used with arrays. So if you will be studying for the test, which I hope you will, make sure you practice a lot with for loops and practice a lot with arrays. Just master those.
All right. I've got the code loaded in the visualizer if you want me to take over.
Yeah, sure.
What that looks like. Cool. Yeah, thanks, Ahmed. All right, my screen being shared. Cool. Okay. So let's visualize this execution. So right here, we have one big list, and these are the two brackets that have it. And inside we have three mini lists. So that's one list, that's list number 2, and that's list number 3. So let's break up this loop a little bit. Let me just change some of the variables so it's easier. So we'll call this for big list. So this is talking about the outer list. So these brackets are the big list. So it's going to be, this whole thing is one big list. This whole thing is another big list. This whole thing is another big list. And that's what gets passed into this variable here. And we'll call this small list. So what gets passed into this small list variable are these individual numbers right here. Is that clear from everybody? Can you understand my variable notation? Do we understand the structure of this loop before I press run? Crystal clear? Awesome. Okay, cool. Now let's execute it. So first we have A. So A, this is a little bit confusing. So in spot number 1 in A, we have a list. In spot number 2 in A, we have another list here. In spot number 3, we also have another list here. Let's keep going. So now we have big list. So as I said before, big list is equal to this entire list over here. And now we're looking at small list. Remember, small list is equal to just this little itty bitty part of this big list. So just that one piece of that data right here. So we printed it. There we go. Next, we look for the next. We're still on big list. Now we're looking for the next tiny thing in big list. So there we go. We're printing the 2. And this is going to happen. So now we have the 3 from this. Now look what happens. Look at this arrow. Where's this big list arrow going to go? Let's watch it. There, look, it pointed at the next list. So at position number 1, we're pointing at the next list. And same thing. So small list, we're now pointing to position number 1, the first piece of data there. We're printing it, and that's going to happen. And then you can see the arrow switched again. And now we're pointing at the next big list right here. Big list and small list, we don't define them. So we kind of do. So what's happening right here is we're talking about pointers. So this first variable right here, it's pointing at this entire list. This variable right here, it's pointing at this smaller one. In terms of the loop, because the loop doesn't, it's a little bit ambiguous and we want to make sure that it's dynamic. Yep, so Python just kind of knows on its own what to do. So because we said for big list in A, so when we're talking about defining things, we have our parent, let's call this grandfather list. So we have grandfather list right here. Grandfather list has 3 kids, and it's got all these little grandkids right here. So we're talking about what's the big list inside of grandparent list A. So we have one child here, we have another child here, we have another child here, and then small list is all of A's grandkids. Does that make sense? Awesome, cool. So yeah, I'm just gonna fast forward a little bit. And there we go. At the end, big list, we're pointing at the final parent. Small list is pointing at the last grandchild over here. And we have our entire list printed. Does anyone want me to go over this again? Is that a yes to going over this again? Or we understand what's happening? I can go over this as many times as you guys want because this is something that I know Vita puts on all her exams. And yeah, you're still confused? Okay, cool. Cool. So let's change the name here. We're going to call this grandfather list. We're going to call this child, and we're going to call this grandchild. Okay. Okay. Do you understand where these little, I guess, my analogy is coming from? So we know that grandfather, it's pointing at this entire structure. So everything that's highlighted in blue is grandfather. So it's anything between these two brackets, it's part of the grandfather. Does that make sense? I'll just break it down step by step because I know this is super confusing. And when you start doing a lot of bigger sets of data, it gets even more confusing. So this is really important. Okay, perfect. We got that. So child, we're pointing at this entire child. We're pointing at this entire child. We're pointing at this. So anything in these brackets, so that's one child. Then we have a second child right here. And then we've got a third child right there. Does that make sense? Yep. Okay, cool. And then grandchild, we're pointing at one grandchild here, two grandchild here, three grandchild here, four here, five here, six over here, seven over here, eight over here, and nine over here. Does that make sense? Okay, awesome. So now let's take a look at what happens when we run. So again, look at this red arrow. So pay attention to this red arrow right here. Okay, so our first step, we load grandfather into our memory. So grandfather has three children, and we have child one over here, we have child two right here, and we have child three all the way at the bottom right there. So our first thing is that we take a look at our loop. So we're saying for child in grandfather. So remember, child is going to point at this whole child or this whole child or that whole child. But because we're in a loop, we're going from first to last. So we're starting at the very first child. Does that make sense? Okay, cool. So now let's look at the next part. So remember, we're still inside child. So now the next arrow, we're looking at, oh, where's the grandchild? So remember the grandchildren for child that we're currently pointing at. So this red arrow that's highlighted right here, it's pointing at this entire child. And we have the grandchild variable that's going to be pointing at this one, or that one. So remember, we have child, and what is child's children? It's these three children right here. So these grandchilds. So let's load up that variable. So we have grandchild, which is equal to the very first grandchild, which is number 1. Does that make sense? Is that a little bit confusing? Okay, you get it? Perfect. Okay. And now we're printing grandchild. So we see grandchild is pointing at number 1, which is right here. So take a look. It's really cool. Look what happens right here. Boom, we have a 1. So that's going to keep going. So now we're still pointing at the first child because we have all of these other grandkids. We don't want to forget them. They're going to get mad at us. So now we're looking at number 2. We're looking at number 3. Okay, so we've counted all the children that this child has. Let's move on to the next child. So there, boom, our arrow switched children. So now this children has 4, 5, and 6 as their grandchildren. So grandchild is going to change to the 4th grandchild, and we're going to print them. This 5th grandchild, and we're going to print him. And the 6th one, and then we're going to print him. And then boom, our arrow is going to switch to the last child. And our last child has 7, 8, and 9. So now we're printing grandchild number 7 printing grandchild number 8 and grandchild number 9. And that's all there is to it. Does anyone have any more confusion? I can keep going over this as much as you guys want.
Looks good.
Okay, perfect.
Okay, so now that we've covered double for loops, I think we should we can go on to while loops and briefly, and then we can go on to string methods, or we can like skip over string methods and just go straight to like answering string-based questions, because I know that's usually a source of confusion.
Yeah. You want to do while loops, or let me take it real quick?
I can take it if you want to. Oh, here, I'll get it. Sharing. I suddenly forgot how to share screens. There you go. Okay. So, and if you'll give me a second. The idea behind a while loop is like this. Just give me a second while I find the actual. So a while loop, what it does is that it takes a condition. So if you guys, do you guys remember Booleans? I should probably ask about that first. Just to quickly go over it, a Boolean widget, like for example, is like awake, right? It's either true or it's false, right? It's a value that can only be right or wrong. And so let's say I say is awake true, right? So while this person is awake, or while this person is awake, we'll print good morning.
By the way, you may get some syntax errors, yeah. And then I don't think you need parentheses as well. I do it a lot with Python. Yeah.
Yeah, my bad. While is awake, it'll print forever, and obviously it'll only go so far because computers have limits. But the idea is that a while loop will check for a condition, and as long as that condition is valid, then it will continue looping. Like for example, if I say if I have has car keys, if I have my car keys, I can open my car. So while has car keys, print can unlock. So as long as I have it, it works. Now, there is something to note, which is that while loops take conditions. They don't need variables. So I can give it, for example, true, or for example, I can give it not false, and not false is just true. Right? So you have to be careful that whatever you put in as an expression in your while loop has to evaluate to true in order for it to run. So for example, if I say while false, this will never run, right? But if I say while not has car keys, it'll evaluate to true, right? And I can just print out the value actually. I don't know why I keep making my variable names this long, but bear with me, guys. And it'll print false. And that's the idea behind a while loop. It takes a condition of whether it's true or false, and while that condition evaluates the true, it'll do it. So I'll give you a more intuitive example. Let's say I had a number n equals 10. And while n is less than 100, I guess I should remove these brackets. Sorry, force a habit, guys. While n is less than 100, I want to set n to equal to n plus 1, and then print n. Strange.
I think it's like you gotta remove the space at the beginning. Like right at n, I think there's a space. Hold on.
Here or
Yeah, so like you see where like now hashtag is kind of more to the left in n. Same thing with any. You have to like remove the space. Yeah, like
okay.
that.
Oh, it's so weird. I didn't even notice that.
Yeah, it's Python.
So here it is. So while n is less than 100, you want to add 1 to your n. And this will go 90 times because 100 minus 10. And so it'll keep adding all the way until it gets to 100, which is the final value here. Right? Does anybody have any questions about while loops? It's of the two loops, it's the easier one, and it's one of those things that's easier to learn, hard to master.
The chat seemed good.
Yeah, chat seems pretty happy with while loops.
Oh,
so
It looks like
can you while
Ken wants
something
some sort
until
of
something?
like a do while.
Well, there is. You
Like,
can't necessarily until something like this. Like you're saying while n until 100, right? I guess that's the only equivalent that we have. But you can do something else, which is called a do while. I don't know if is that supported in Python.
no, what you could do is just break and continue. But I maybe one way to answer this question is to, let's say, ask a user input at the beginning, and while the user input is not equal to this value, do keep on doing stuff until the user input is equal to some value.
Yeah. So here,
Right.
actually, I can give. I don't know if this will work with while. Actually, no, this won't work. My bad.
If you want, maybe I can quickly take over here and give a quick example. I don't know if you'll see my edits. Want me to share?
I'll stop sharing because because this is more your domain at this point.
Yeah.
You made these exercises.
So let's say at the beginning of my Python program, I ask for a user input. So let's call this user input. And this is obviously equal to an input. What is your name? Right? Or what is your favorite color? Right. And then we'll say while user input is not equal. So my favorite color is blue, the blue. Print, are you sure? And then yet again, ask the user for an input, right? So basically what will happen during this entire while loop is I will keep on asking the user. Thank you. I will keep on asking the user for an input until he puts in blue. So if we run this, what is your favorite color? Let's say orange. Are you sure? And now it'll ask me again. Green. It'll ask me again. But if I put in blue, it'll finally finish. So I guess that's one way of kind of having do something until that with user input. Does that answer your question? Yeah, that's how the prof explained to in examples. Oh, great. I didn't know. You want to continue with while loops? I guess that's really it. Right, there's more advanced stuff, but I'm pretty sure Vita didn't teach continue and break, from what I remember.
I mean, continue and break are useful, but like we can breeze over them if you want to. Although they're usually recommended against. I don't know why. Yeah, just feel free to go over. Feel free to go over breaks and continues unless we get like rejections from the chat. You know.
Okay. Yeah. So if you guys want to go over something else instead of continue and break, just say in the chat right away. Do I don't know, do that. But while you guys are not doing that, I'll actually go ahead. So let's start with break. Break is probably the easiest one to understand. So break, as it mentions, it completely breaks the loop. Even if the condition is still true, I want this loop to break. So let's have an infinite loop while true, right? Let's also have n is equal to 0. And every time this loop runs, we'll add, can we go over pass as well? Yes, we can go over pass. It's super cool. So let's say every time I run this loop, I want to increment n. So I can do n plus plus. And if n is equal to 10, then I will break the loop. So let me actually print n over here just to show you guys. I guess I'll do this. Maybe I'm thinking in Java, JavaScript. Okay. So this loop right here is infinite, right? It should never end. It's always going to be true. But because I have a break statement, it will break the loop. So that is probably the easiest way to explain break. Next up, we have continue. This is a bit more tricky. I'll put an example 5. So what continue does is, I guess the easiest way of saying it is it resets the loop. So let's say we have n is equal to 5. And while n is greater than 0, so while n is always bigger than 0, I want to do n minus equal to 1. So I subtract 1 from n every time this loop goes. Oh, whoops. Jesus Christ. And if n is equal to 2, not to 1, to 2, Jesus, print, actually, no, just continue. Makes more sense. And then if it's not equal to 2, then I just want to print n. So what will happen here is that it will print 4, 3, 1, and 0. Once it reaches 2, it will reset the loop. It never reaches this statement right here because it's like, oh, continue, let me reset the loop. So that's what continue does. And yeah, that's really it when it comes to while loops. Is there any questions regarding that? My Zoom chat is not open. Chat. Okay, there seems to be no questions.
So far that we see, yeah.
I guess what's the difference between pass and continue? Okay. So pass, I guess I'll explain what it is real quick. Pass is more syntactual sugar. So let's say I have a function called main, right? And then I don't want to do anything in main, but I still want to have that function declared, right? If I just run main, it'll give me an error, right? It'll say main has to have some content. There has to be something in that block, right? Then I'll just run pass. Pass is a do nothing. It just does absolutely nothing, right? It's just there to make sure your syntax is okay. That's all that passes does. If we put continue here, or sorry, if we put pass where continue is supposed to be, you will see that it actually prints 2, right? Because as I mentioned, pass does nothing. Continue will actually say reset the loop. I want to stop this loop for a bit. I want to continue it, but just stop this current increment. So that's the difference between pass and continue. Pass is just there to be syntactual sugar, make sure everything looks okay. Continue actually does something. Is there any other questions? If not, what do we have left real quick? So we have recursion, strings, and if and else, and I'm pretty sure we have, yeah, up monotone.
We can, okay, we'll ask the chat, like, do you guys, I mean, we can go over strings, but do you guys want to go over like up monotone? Because it is like a string-based question as far as I recall.
There's also square free. I know a lot of people had issues with square free.
This is true. Okay. So is that like in favor of questions?
Yeah, everyone seems to go like questions.
Okay.
So
let's start with up monotone. Or actually, let's start with square free. I think that would make more sense.
Yeah. Okay, perfect. So I guess I'll go over the way I did square free. Let me just pull up something real quick to make my life a bit easier. Don't mind this. So let's open up OneNote and kind of do this a bit more visually, right? So what SquareFree wanted us to do is, let's say we have a string called M A B A B, right? SquareFree wanted to check if there was a pair of words that were right next to each other. So over here, AB and AB are words that are paired and are right next to each other. Thus, the string is not SquareFree. However, if we had AB and AB, right, two pairs, but they're not next to each other, the word is SquareFree. So this will return false. It is not SquareFree. And so we'll return true, that it is SquareFree. So how would we implement this? Well, this is kind of my way of visualizing it. This is my problem solving. So I will make a bit more space here. It's kind of divided. So let's start with that actual string MABAB. So what does a pair have? So MABAB. So a pair has one, a length, right? In this instance, the length is 2. And 2, a position. And strings can be treated as arrays. So we see that this is 0, 1, 2, 3, 4. So its position starts at 1 and then goes to 3. Like I know it goes to 2, but for this implementation, say it goes from 1 to 3 because it's 2 words. Because 1 plus 2 is equal to 3, right? So we have 1 over here and 2 over here. So that's what a pair has. So what we would do, first of all, is let's compare every single letter, character, and then start going upwards. So we'll start with 1-letter pairs, 2-letter pairs, 3-letter pairs, and 4-letter pairs. And we'll check if each one of those substrings, we'll call them, is found in that string. So let's say we have M, A, B, A, B. We start with M, right? I want to run a check. I want to ask, is the substring N found twice, right? Because it needs to be a pair, found twice in the big string, right? And then it'll give me no. If it's no, then let's just forget about it, right? Who cares? Next up, we have A. So M, A, B, A, B, right? Is A found twice in the big string? In this case, yes, right? Oh, so we already have a pair. So that's the first condition that's been met. The second condition, we want to see if that letter A is next to its other pair. So how we would do this? Well, let's define what next to means. So next to could either mean in front or behind, right? So if we have A, its pair would have to be here or here. So how would we do that? Well, as I mentioned before, what defines a pair is not only its length, but its position. So to find the pair before, we would have to do, so let's say value, or actually other pair behind it is equal to A's current position. So A position. Sorry, I always write on the diagonals. It's a bad habit of mine. A position minus its length, right? So that's where the other pair would theoretically start if it's there, right? And if we check, if we then slice the big string, so if we slice it from A's position minus length, so let's say A is 1 and its length is 1, so A1 minus 1 is 0. We will check if A of 0 is equal to A, right? And if we go up, we see that A of 0 is M. Thus, that does not count as a SquareFree variable. Now let's go and do it in front, right? So we would have to do a position plus length times 2. The reason we're doing times 2 is that if we just did the length, it would give us the ending of A. But I want to do the next variable in front of it, so I'd have to do B, right? So I actually have to multiply length twice to get value B. Another way to explain it is to actually do the math, right? So the position of A is 1, and the length is 1 times 2. We get 3. And then we have 0, 1, 2. Hold on. I didn't. I did my math wrong here somewhere. Hold on. Yeah, it's not my times 2. Sorry about that. I got confused with something else. Anyways, now we have a way of checking if the pair is behind or in front, as well as slowly going through the big string and kind of categorizing small strings, right? So now that A is not a square, it's not a square free variable, we would continue with MABAB, right? Yes, but then the same thing would happen with up here. And then MABAB, right? It will return yes, but yet again, it's the pairs not next to it. And then MABAB, yes, but the variables are not next to it, so it's a no afterwards. And now this is where it gets interesting. We went through the entire string, and now we want to kind of update the length, right? So I will do MABAB, but now with a length of 2, right? So now the same thing would happen. I would compare MBAB. Is MA found twice in the big string? No. Is MAB found twice in the string? Yes. Is this other pair right next to it? Yes. So now we have found the logic to how we should implement this, right? This is a process. So now let's actually try and code it. By the way, before I continue, are there any questions about how this logic works? Sorry, my phone's ringing.
Just in the YouTube chat, we have somebody who says they're a little bit lost. I think with like a more concrete code example might help. Do you mind coding it on the Python visualizer?
Yeah, of course. Can you send me the link in the Python visualizer?
Yeah, 1 second.
Oh, I think I found it. Yeah, I found it. Beautiful.
All right, I just threw it in the chat again.
Perfect. So, just for like my own sake, I'll create the function called square free, right? Habit of mine. Pass for now, and then we'll call square free. And then we'll pass it in, let's say, MABA. So first things first, the first thing we do is we have the length, right? That's the pair has 2 properties, length and a position. So we'll call it stored length, and that's equal to 0. Actually, we don't even need this. Yeah, we don't even need this. So first of all, for length in range, length of s divided by 2. So this code that I wrote right here, what does this mean, right? This is a bit much at once. So basically, I want to iterate through the big string s. So it's called big string, right? All caps. So over here, we'll see that MABAB will give us has length of 5, right? So length of big string is 5. Afterwards, we're dividing it by 2. Why are we dividing it by 2? You may quickly ask. Because a substring can only be at most half of the actual string. You can't have MAB and then have another MAB and MABAB, right? It's 5. You can't have 3 plus 3. It doesn't make sense. So to save some time, I just divided the entire entire string by 2. So it can at maximum have a length of 2, right? And the reason why there's 2 slashes here is because it's an integer division. It'll make sure that it's an integer. Next up. So for position in range of length S. So what does this next for statement mean? So now we actually want to go through the entire string, right? We have the length, and then we want to get the position. So big string, right? So for position in range of length of S, right? Let's say position now will be 0 in the first iteration, right? So if we do print big string position, and we did print position, there's no errors. How do you get the console on here? Oh, my bad. Oops. What is going on? Sorry.
Yeah, just press close. That's for their own debugging of this software.
Oh, okay. So you'll see over here, 0, M, right? So M is at the 0 position. A is 1 is A, 2 is A, and so on and so forth, right? So now we have the ability to actually print out the position. Perfect. Now let's actually grab the position and the length. So what we can do is we can say start at this position and then end at position plus length. So now this will print out the entire substring. So to make it a bit more easy to visualize, substring, and then get rid of this, add a space, visualize execution, and just jump to last. You see, obviously it starts at 0, so it's going to print out nothing. Then we have M, A, B, A, B. Get rid of this for now. I'll tell you guys why later. Last. Then we have MA, BA, B. Then we have 2 substrings. We have MA, AB, BA, and then AB kind of goes through it again, and then B. Right. So now we have the ability to print out the entire substring. Awesome. So let's actually put that substring into a variable. So substring is equal to big string, right? And then we slice it. Now we want to see if that substring is found twice in the big string. So we can use the count method. So if big string dot count substring is equal to 2, right? So that means this substring is found twice in the big string. We can do, well, now we know, let's do this. So substring and then substring found twice. So visualize execution, last. So we see that A is found twice, B is found twice, A is found twice, B is found twice. AB is found twice, AB is found twice, B is found twice, right? So now we have a way of grabbing our substrings and actually seeing if it's found twice. So next up, and this is probably the most complicated one, is to actually check if those substrings are next to each other. And this is where we kind of use that math I showed at the beginning. So I'm just going to kind of write it out real quick. So if the substring, right, is equal to big string, we'll do position, right? So we have the position plus the length plus 1. This is why I was having this issue at the beginning. Because yet again, the length in an array, right, it starts at 0, but we want to start at 1. So we need to kind of do that. To position plus length plus 1. And then as I mentioned, we have to do it twice. So plus length plus 1. or so this is to check if that substring is in front of it, or if value is equal to s position minus length minus 1 to position. And then return, return found, return false. Over here, return true. So what does all of this mean right now? So let's go through it again, right? So first of all, we're going through the entire length of big string. So from smallest to biggest. Next, we're going through each position. And then we're grabbing the length and the position, slicing up the big string, checking if that substring is found twice in the big string. And then over here, we do some quick little slicing to check if that substring is next to it. So let's just visualize execution to make sure everything works. There's no errors. Okay, beautiful. So we have substring A found twice. And then values not defined. Hold on, sorry, there's another. Okay, my fault. It's not supposed to be value substring. Oh, oops. Okay, perfect. And then we'll print the return statement of this. Okay, beautiful. So over here, what we did is let's go through the steps. So let's go to first, right? We initialize it and then we pass it in M, A, B, A, B. So now we have the length of 0, right? We have a position of 0 and we have a substring of M, right? We're going to go through it again. Now we have a position of 1, a substring of A, right? A is found twice. So substring A found twice, but it doesn't pass this check right here. So now we're going to go through it again, right? B is found twice, right? Is the next B to the left or to the right of it? No. And this just keeps going over and over again until we have a length of 1, right? Now the substring is MA, right? Is MA found twice? No, right? Is AB found twice? Yes. Now, does AB pass the test of is it to the left or to the right of it using our slicing? Yes. So now we return a value that's false. I'm a bit short on time. I tried explaining as much as possible with the limited time I have. Are there any questions regarding this?
Adam, if you scroll down a little bit, I think there's an option to create a permanent link of this code. So maybe if you could put that into the chat and I'll put it into the YouTube live, they can actually parse through all the steps on their own and just kind of take a look and see how it's all working. Oh, wow. Okay.
Yeah, it's a bit of a long one.
Big link, but also we can. The other thing is that we also have a document, like a commented document that we will give to you guys in the Discord, hopefully in a few. And it's going to be read only, but it has the solutions to all of the questions, because we will admit we did this beforehand and we wanted to do it live to make it easier to follow through. Yeah, we're coming clean. So we just need a couple minutes to move the stuff we put here into the document, and then we'll be able to release it for you guys in the Discord. And yeah, we won't release it on YouTube live because that'll be over by then.
Yeah.
I'm also going to be tossing out a survey on the Discord server and in the YouTube live chat, because we're probably going to do more of these, I think, right? I think.
Yeah.
Actually, I also did do a poll. Could you also, Adam, could you put out the last 2 questions of the poll as well?
Of course.
Actually, if you already have the survey, we might as well just do that first, and then.
Let me just launch the poll. Okay, I'm just gonna launch the poll.
Question.
By the way, on my end,
Actually, can
yeah,
you
go ahead.
launch question 2 instead of 3, or does it only let you launch them
It'll,
sequentially?
yes, I have to do all of them, sadly.
Okay.
Anyways, bit off topic. If you guys ever want to reach me, my Discord is, I'll paste in my Discord right now. Sean, Ahmed, if you want to give your links as well, if anybody has any questions, that would be good.
Yes. Actually, here, do you mind if I join this server? I know I'm not technically part of this class, but
Yeah,
just
by all
so
means,
that
go
like,
for it.
Yeah,
I
go
can
ahead.
answer questions.
All right. So yeah, we're talking about the ITI. Yeah, I'm the data bending. Sean, here's Kuzent. I'm sorry, we're exposed.
Oh, no.
Oh no, but if you ever want to reach any of us and ask questions, I'm more than happy to help you guys out. Already getting friend requests. Okay. Okay. My bad. I thought I can only do all of them, but I can only do one at one. One at one. So I'm gonna do launch poll 2. So if you guys can go ahead and quickly answer this poll for me, that would be fantastic. Oh, no problem.
Yeah, these are, by the way, these polls, we made them to gather like information about just the teaching and how well it was, because we do want to like keep knowing what we did well and what we didn't. So this would really help us in knowing how we did.
It also helps you guys. Oh,
I toss a survey out on the Discord server as well, just
awesome.
so in case
Perfect.
people are catching the recording as well.
Can you change my role to admin?
Yeah, I'll set you up.
Roles. Oh, there you go. You got the mod. Is it an option for none of the above?
Yeah. In the ITI Discord, do you have like some sort of role for mentor? I think that would be better for me and Ahmed rather than being admin. That way we can support you guys.
I have Python Genius.
Yeah,
do
do
that.
you have Python Genius? Let me just make sure the. Actually, no, I can't modify it. You have to modify that.
Yeah, I gave him. Okay, I'm gonna go to the next poll. Just thank you guys yet again for doing these polls. Helped us a lot.
I can't tell if that's waving or raising their hand. Joshua, are you raising your hand or waving? Oh, that's raising hand, my bad. Joshua, I think, has a question.
Yeah, if you want to ask a question, go ahead.
Okay. Sorry.
Oh, he was clapping. Will you make further revisions for the test? A bit confused. We don't make the tests.
Yeah, we're not TAs.
We're not TAs.
Unless you meant something.
I'm in the class currently. I haven't passed it yet.
Soon.
Yeah. For future tests,
okay.
yes, we can. If you guys really enjoyed this review session, please complete the surveys, join the DSC Discord, support us, follow us, then we can keep bringing you guys more workshops like these.
Random question.
Oh,
you guys
boy. Oh, Ahmed, do you want to answer this one?
Wait, digital systems was can you remind me?
That was with Fatty Malik, where we learned nodding and all that stuff.
Okay, so digital systems is great if you're into electronics and like circuit design. It does get complicated very quickly, so you do want to start with, like, you might want to do yourself a favor and go on their syllabus and learn the basics of like Boolean algebra, because it basically deals with binary operations and binary math, which is like and statements, or statements. I know I'm not doing it justice because I could not explain the topic in 5 minutes, but as long as you prepare beforehand and really like try to read the material before the lecture, you should be fine. Right? It's complicated, but it's not impossible.
Yeah, and I agree with what Ahmed said. The course, it's kind of like calculus. If you found it like calculus really fast paced, then digital systems kind of does the same thing. So if you get lost at some point, go to office hours, bother your TAs, and the profs that teach digital systems, especially if you get Fatty Malik, he does an amazing job of supporting students and answering questions. And he absolutely loves it when you ask him questions in class. And his explanations, I found them really helpful. So as soon as you find yourself getting a little bit lost or not understanding a certain concept, go to his office hours, bother his TAs, because trust me, when you get to that final, all these little things are going to add up, and it's not going to be a good time.
One question that I have for the rest of you is, what do you want to see like other kind of workshops, right? So like other languages, right? Maybe something of interest, like web development or C++, right? Or Go. Just go ahead in the chat and let us know what you guys want to see.
Yeah, I wish I made a poll for that actually.
Yeah.
I can set that up. I can just add it to the SurveyMonkey thing.
Can we have a little caveat where we make them sign up for the club before they can?
We create a survey to see what they want to learn, but it's only going to be posted on the DSC Discord.
Yeah, but your result doesn't get posted unless you sign up.
There's definitely a way to do it.
Yeah, if you guys want more support or more resources, definitely join the DSC club. It's a no commitment policy, so just come out to the events you're interested in or events you want to do, and it's a good time. And especially as a co-op, we do have interns. So myself, I work at BlackBerry, and I'm working for Microsoft in the summer. Ahmed's at the CRA, and some of our club members, they're working at Google, they're working at SurveyMonkey, they're working at the government, they're working at Nokia. Some of them are in hardware, so they're working at Synopsys and for the Royal Navy. So there's a whole bunch of supports there and resources and people you can network with who have gone through basically what you guys are going to be going through. So I definitely recommend joining the club, even if you don't want to come out to the events, just having that opportunity to network with other co-op students and potential recruiters from Google, because we are a Google club. Those are invaluable. So make sure, check out our Discord, join our mailing list, and just stay in the loop.
I see Joshua asked, he's intrigued in C++. Great to know, front end versus back end. Super interesting and essential, and doing more practical coding exercises. So would you like to see, for example, like projects like, like I know we've had like cloning Facebook workshop, I think like a week ago. So something like that, would that be interesting? Yeah, that would be cool. A workshop about co-op in the CS software engineering field.
Yeah,
I'd say
we
so.
could definitely do that. That'd be fun.
Maybe for us, maybe like on the website, we should have like a little section like give us your ideas, right?
Yeah, for sure.
That'd be pretty cool.
Yeah, that'd be cool. Yeah, if you check out our YouTube channel, we actually did a resume roast. So we're talking about what things employers are looking at for resumes, how to structure your co-op resumes, keywords you should be putting on there to get through all those keyword filters. And we actually had an awesome guest speaker who interned at Tesla, Google, Microsoft, and Intel. And he was talking about his resume. He had some tips and tricks about how he got recruited by all these companies. And he's only 1 year older than me and Ahmed. So he's in his 4th year, and his first co-op was at Intel. So if you guys want a really awesome mentor or a person just to look up to, definitely join the U Ottawa DSC. He drops into our events from time to time. He's a really, really good guest speaker, very open, very approachable. So definitely check out our YouTube channel. All the recordings are there. Yep, so our LinkedIn workshop was also recorded. It was featured on Think Outside the Valley. So that is Google's YouTube channel for their DSC chapters. So if you just Google Think Outside the Valley YouTube, those videos should pop up as well. So those are the international events that we partner with DSCs around the world. So those get posted on that channel. Internal U Ottawa events get posted on the DSC U Ottawa channel. Yeah.
All right. I guess we can wrap it up. Any last questions?
Yeah.
Thank you for being here.
Oh yeah, for sure. It was awesome talking to you guys and teaching you. And yeah, at one point, all of us were at the same starting points as all of you. We all came from a background of absolutely not knowing how to code. So if you're feeling intimidated or overwhelmed, just ask questions, reach out to upper year students, reach out to your TAs, reach out to your profs, and I guarantee you everybody is going to try their best to help you as much as possible.
The best feeling is looking back to your code like 1 or 2 years ago and just being, this is disgusting. I'm so happy I improved. That's one of the best things you'll have when you keep practicing. That's for sure.
That's for sure. Yeah, and if you guys have questions about co-op, I know when I was a first-year software engineer, I was really scared about not finding a co-op job or not getting placed. So I can definitely help you guys out with that in my journey. So definitely reach out to me on Discord. We actually have channels for asking questions and mentors. So make sure you join our Discord and get connected and ask all your questions. Yeah, for sure. No worries.
All right, goodbye to the rest of you.
Oh, they are leaving. Sorry,
Yeah.
I wasn't sure.
Slowly but surely.
Slowly but surely.
Come on, guys, go.
Go, go, go!
Get out of here.
We should discuss adult things. There we go. Yeah. As soon as you bring up taxes, they want to scream. Okay.
Also, if you want to stop the YouTube live stream, it's probably a good idea.